So I am the PI, as Harry said, of the ProTECT clinical trial, which is an NIH-funded clinical trial. Just while we're getting into that, my conflict of interest slide that I need to present. We're not going to talk about DTECT, which is the sideline assessment for concussion, which is pretty cool, but if you want to talk about it afterwards, I'm happy to. But BHR Pharma, which is putting on the Symposium, licensed the technology for progesterone from Emory. I'm listed as an inventor on the patent, so therefore eligible for royalties if it goes forward. So you just need to be aware of that. I have no other financial relationship with BHR. All right, so I think we're talking to neurosurgeons, so there's probably not a lot of mystery here about how big of a problem traumatic brain injury is. You know, the thing about, we look at these numbers and we just go glazy-eyed. I mean, really when we talk about trillions in our budget, when you start looking at these kinds of numbers like 52,000 and over 1 million in the emergency departments, it just kind of becomes numb. How many people in here actually flew here? Was in an airplane? Okay, very good. So let me just put it in perspective. 52,000 deaths is actually 175 airliners going down every year. Okay, would you get on an airplane if that happened? No, we would not be having this meeting, I'm telling you. And the FAA would shut the airlines down. I mean, they stopped Boeing just because there was a little fire in a battery box, right? So this is a serious business, and the problem is that we have no solutions to this, and yet we go on like nothing's happening. But 52,000 people are dying every year. So it's a big problem. I showed this slide. You know, I have a lot of admiration for neurosurgeons, and I would probably be one if I didn't mind spending 15 years of my life in training and then staying up all night and all the stuff that they do. But even a neurosurgeon can't fix this problem, which is best quoted by Richard Feynman, basically a Nobel Prize winning physicist, that it takes very little energy to scramble an egg, but all of science is incapable of reversing this transaction. So once you've had a traumatic brain injury, you're in trouble. And no matter how good your surgeon is, we can't really fix that with a knife, okay? So there's other problems. So what do we do? What is traumatic brain injury? Well, once you've had this event, once you've had the injury, remember we used to think of TBI very similar to stroke many years ago, which was once you've had the injury, you put the person in the corner, and how they do is how they do. Okay, we see if grandma woke up or she didn't, because there wasn't a lot of treatment before TPA. Well, TBI is sort of in that kind of phase, right? You get the injury, what do we do with the patient? Well, a lot of research has gone on, and we now know that there's a lot more than just that original injury, and this is just really to sort of put everybody on the same playing field. And what we've learned is that there's a whole secondary cascade, what we call the deleterious or neurotoxic cascade, that occurs after injury. And it's very interesting. The first evidence in this really came out from studying the NMDA channel, this N-methyl D-aspartate. I promise I won't get too deep in the weeds with this because even I get bored. But the bottom line is we found that in animals, if you really could, you do the injury, yes, you've got injury that you can't completely repair from that injury, but if you can stop this neurotoxic cascade, the outcome of the animal will be amazingly better, a lot better. In fact, probably a majority of the injury of survivable TBI occurs after the event, okay? So that's a really important scientific discovery. And so this NMDA channel was really, in the very beginning years, 15 years ago, something like that, when a lot of the antagonists, MK801 and some of the others that were studied. So, but now we know it's a lot more complex than that. And I show this slide, this just is just one series of the different pathways that are activated after TBI that are all deleterious. So it's very complicated disorder. And just to kind of simplify it down, you can see this where there's all sorts of things, inflammatory cytokines that are released that cause edema. There's cerebral edema that occur both from a vasogenic and a cytotoxic origin from the cells themselves. This is cytotoxic cascade. That's the NMDA channel. That's just that one little tiny piece of this. But you can see all of these other things that are occurring are very significant. That leads us to this, which, as I've said before, this is my favorite slide, which describes two elements. One is that unfortunately the graveyard is full of our patients, and the other is the graveyard is full of all the treatments that have been tried in the past. Okay, so we know that unfortunately this is where we are. There's really nothing that we have in our toolbox other than maintaining good patient care and trying to prevent the patient from herniating that we can do for these folks.